Hello, welcome back everyone. Hope you had a nice 5 minutes. We will carry on where we left off. So we've finished standards 6.1 and we'll move on to minimum standards of fabric and services, which is standard 6.2 onwards. So we've looked a lot at minimum U values and things already, but 6.2 sets the absolute upper limit or limiting heat loss standards for our thermal elements. Again, because we're trying to make progress and improve our buildings, there was a commitment from government to improve the limiting U values applied. The way they did this is they looked at EPC data over a 4-year period, and they found that most dwellings were built close to the limiting standards, if not better. So what they did, they sort of analysed what the standards that were being set, and then they basically reduced the minimum U values to around those standards. So there was 2 options proposed. Option 1, you can see there, so the external walls couldn't exceed a U value of 0.17, or option 2 was a bit more ambitious, 0.16. Okay. Key things to say really is that these are the sort of the upper limit of U values you can build to, but the notional buildings we looked at earlier uses U values which are more ambitious than this. So whilst you could build to a U value of 0.17 or a floor of 0.15, it would harm your chances compared to the notional building, and you'd have to make up for that shortfall elsewhere. When they analysed these standards, they found option 1 was achieved by 50% of new homes and option 2 33%, and they settled on option 1 as the new standards. Okay, so you can see compared to section 6 2015 there is a bit of an improvement, but really nothing that should be scaring developers too much at the moment. They did look at an alternative solution. So if you wanted a bit more design flexibility, rather than building to the standards there in option 1, they acknowledged that because of the use of low emission heating or renewable energy, there may be a scenario where actually you want to build to a slightly different U value or use a slightly different amount of glazing than in the minimum standards. So they've brought in an optional way of demonstrating compliance, which gives you more flexibility, called the dwelling space I can't even say it. Dwelling space heating demand limit. Okay, and that is using SAP, and it's calculating the space heating demand of a building based on the minimum standards in option 1, and then your actual building space heating demand is compared against that theoretical value. And if your actual demand is lower, then you are also compliant, even though in your actual building you may exceed some of the standards here in the option 1 column. Okay, it has to be done on a single dwelling basis. You can't average it across blocks of flats, all right? But it is something that SAP assessment software will do for you, and certainly our software that we're developing at the moment, there's a tick box where the assessor sort of ticks to enable this method of compliance. Now, space heating demand is already used in section 7, and it can be obtained out of the SAP calculation worksheets. But to give you an example, we've got a dwelling here. For some reason, the walls aren't going to be built to the limiting value of 0.17. They're going to be built to 0.2. However, they've made up for that by improving the floor, and the roof's the same, but just improving the floor alone in this instance resulting in a space heating demand of 20 kilowatt hours per meter squared per year, and that's compared to 25 in the limit, the space heat demand limit. So therefore, that is still a compliant dwelling. Okay, not quite sure how often this will be used. We do struggle to think of scenarios where you should be able to build to those minimal standards at all times, really. But this is a permitted option if for some technical or economic reason they can't quite meet one of the limiting fabric parameters in 6.2. For thermal bridging, the government have accredited construction details which are available, free to download and use by SAP assessors and developers. It was proposed not to remove them so much, but not update them. So they're dated 2015 based on sort of the constructions used in section 6 2015 for compliance. Obviously, we're probably going to be building our walls, floors and roofs slightly differently now. So it was deemed that they're out of date. And in reality, they're probably not going to be relevant for the way we're going to construct our walls, floors and roof going forwards. But the government haven't proposed to produce a new version just yet. There are quite a few other free publicly available schemes out there which SAP assessors can use. Some of which we've been sort of advising our SAP assessors to go and look at. LABSS, I know it's not necessarily relevant north of the border, but they do have registered details available, which is sets of construction details, which if the client builds to, the SAP assessors then can claim the benefit in their SAP assessment for. Okay, BRE have a scheme, Concrete Block Association, CBA. Some of the insulation manufacturers, so Extra Therm have details, Kingspan do as well. APA is Aircrete Product Association, so that's for lightweight blocks. All of these have freely available resources where SAP assessors and developers can go and find junction designs and build to that to create some savings in their SAP assessments. If they don't use an established detail, or the client isn't willing to confirm what they're building to, as weird as that sounds, the SAP assessor then has to use a default, which is really penalising, especially now we've had a 32% uplift. It's going to be extremely difficult to comply using defaults. So they really should be getting familiar with many of these schemes to give their client different options going forwards. Air tightness testing. So there's some changes to standard 6.2.5 in terms of the sampling rates for air tightness testing, test methods, and the methodology itself. A bit of context. Air tightness has been around for a long time. It's been part of the building standards since the early 2000s. It's a really good indicator of how well constructed the building's envelope is. And as building standards have tightened and tightened and tightened, there's been more of a push to improve air tightness because it has a significant impact on your SAP score and your energy efficiency rating. Obviously, it's also inherently connected to indoor air quality as well and overheating risk. So air tightness is great, but if you don't ventilate the building right, then you're going to have air quality issues. And if you don't have enough free area to prevent overheating, you're going to have overheating issues. So there has been some unintended consequences of this drive to super airtight homes. There's been concern around air quality, particularly around developers not using the right ventilation strategy based on the air tightness. It's probably a bit more black and white in Scotland than it is in England, but certainly if you've got a dwelling designed of less than 5, it shouldn't be using system 1 ventilation. It shouldn't be using intermittent fans. It should be using continuous extract. However, what happens if the air tightness unexpectedly achieves a score of less than 5 and that system's no longer appropriate? How is that dealt with? What immediate action is taken? And is that then passed down to all the other house designs on the site? We don't know, but there has been some stories of it not happening, which then results in poor air quality and mold and condensation and things. Okay, so it's air tightness, energy ratings and ventilation are all inherently linked, and that's why they're all updated at the same time within building standards. So what's changed? Currently, on large sites, you can sample of between 1 in 20 dwellings in terms of its air tightness, which is great for developers, I suppose, because it keeps the costs down, but it doesn't then mean that all of the dwellings that are not tested have a true picture of what their ventilation strategy is. And again, does that then, how can we be certain that the ventilation system they've got in is adequate? The government estimates only 35% of all dwellings are tested, average score between 4.4 to 4.5, which should mean that all new homes are having continuous ventilation, but we know that doesn't always happen. So they've changed it this time around to make it much more stringent and basically say every new home must undergo an air tightness test. Okay, so there's no sampling allowed anymore. It's simply every home must be tested. Okay, It's great for air testers. There was some concern about, really rural areas or areas in the outer islands in Scotland. How easy it is. Is there an abundance of air testers out there? Probably not. How easy is it to get an air tester out there because they have to rig all the equipment over with them? But nevertheless, the government have said this is what they want to do. So all homes must be air tested from now on. If you've ever seen an air test in action, you'll know how it works. But there's one method currently called the blower door method, which is where they remove one of the external doors and they fit basically a big fan to the door and they pressurize the building. And then basically the fans runs at different speeds and they work out how hard that fan is working. And obviously, the more leaky the building is, the harder the fan has to work to keep the building up to pressure. That's done at a pressure of 50 pascals, which is pretty high, and it's certainly not reflective of what you would live in, but it does stress the building envelope, so it's a good check to make sure there isn't any leakage where there shouldn't be. There's a new method that's come along called pulse, which now sits alongside the blower door as a approved test method. So testers can use either method. You don't get a benefit in terms of SAP for using one or the other. They're just alternative ways of testing. Right. There are some differences between the methods, mainly around speed. So the blower door has to run for about 10 minutes, whereas the pulse test is a much quicker test, only a minute or so long. The downside to that is the blower door can be used to identify leaks in the building envelope. You can actually walk around and sort of feel the leaks or use a smoke pen to see where the air is going. Pulse can't do that on its own. You have to buy a separate tool because it's such a short test. Okay, it costs more. It can't depressurize a building. It can only pressurize, which is important for passive houses, but it's a lot quicker. So, like I said, there's no right or wrong. They're just different methods of testing, but both are now allowed in new homes, Section 6. Probably one more for air testers, but the air testing methodology, which defines how we do air tests, is currently written by ATMA, which is also one of the two competent person schemes for air testers. Due to potential commercial bias and conflicts of interest, there's been a change, and that is now being replaced by a new CIBSE standard, TM23. Okay. So that is coming in alongside Section 6 2022, and that methodology does cover both blower door and pulse methods. Elmhurst also run a testing competent person scheme. So that guide is available for EES, Elmhurst Air Tightness Scheme testers. Okay. Moving on. We'll look at standards for existing dwellings now. There's not so many changes to work to existing dwellings, to be honest, compared to what we've looked at for new homes. But there is some changes to 6.26 to 6.28, which will result in slight differences in how we design and how we treat that type of work. So, standardizing fabric values. Section 6 2015 has different standards in terms of the U values that fabric needs to meet, depending on whether it's work to, I think it's a heated conversion, an unheated conversion, a new extension, a new dwelling, all different standards, which is quite confusing. It was proposed that actually it'd be a lot simpler, and because the insulation sort of quality of insulation out there is so good now, it'd be proposed actually to just have one set of standards rather than all these different tables for different types of work. And the government thought that would simplify the document and make it easier to follow for developers. We've already looked at option 1 and option 2. We know they went with option 1, but also there was a proposal to sort of standardize option 1 for all types of work rather than just new dwellings. So if you built a new extension, for example, your wall would still have to achieve 0.17, whereas in the previous section 6, it got different standards to meet. That got quite a lot of support. So BSD did decide to take that on. So there is only one set of standards now for our thermal elements. Okay. it's general comments where it was providing clarity and it's a better understanding of the requirements, but there were some concerns. Obviously, those U values are pretty ambitious when you talk about conversions, for example, and you're working with existing building envelope. That could be pretty tricky to achieve. Okay, that might be where the space heat demand method comes in, where you get a bit more design flexibility as well. Okay. There was a comment in the Section 6 document to say sort of meet these standards where it's reasonably practicable, but there wasn't much clarification on what that actually means. So that's something that needs a bit of clarification from government, really. And there should be a compensatory approach. We talked about space heating demand limit. So there might be some examples where, particularly for conversions, you just can't meet some of those U values. And that's where you might want to use the space heat demand limit to give a bit of flexibility. We've already seen option 1 is going to be used. So I'll skip across that. Okay. So just to summarize, Section 6 2015 standards on the left, Section 6 2022 for all types of work, standards on the right. Okay. Minimum building service efficiencies and controls. Currently, they are contained in the Scottish Domestic Building Services Compliance Guide. Okay. The consultation looked at this and thought there were a few changes they could make. You could incorporate that guide into Section 6 itself, so we don't have to look at all these different supplementary guides. Everything's in the standards document itself. You could remain it as a separate document. You could somehow take the minimum standards and put them in Section 6 and just have the guide as guidance. And also they were mindful that England and Wales have chosen to adopt their domestic building services compliance guide into the approved documents itself, which does make it a very, very long document. Most people favoured incorporating it into Section 6, but there was a bit of a mixed reaction, really. The government decided at the moment they're going to keep a separate domestic building services compliance guide. So there is a 2022 version now available. Okay. They will consider that again in future when they look at sort of a wider review of all the standards and publications. But for the moment, there is the Section 6 guidance, and then there's domestic building services compliance guide. There's a separate document. There's some changes to minimum standards. So we have seen an uplift. These are in line with what's gone on in the rest of the UK. They're nothing, again, really, that developers or manufacturers should be worried about. So we've seen a uplift and a change actually to how we look at boiler efficiency. So historically, we've used something called SEDBOOK efficiency, which needed an 88% efficiency if it was gas. Now we're moving to the ERP rating methodology of efficiency, which is 92%. They're not directly comparable, so you can't sort of say 90% SEDBOOK is 90% ERP. They work slightly differently. And the boiler manufacturers should have literature on what their ERP ratings are for their products. But certainly, having looked at quite a few out there, none of them should find 92% a real challenge. Heat pumps, slight increase in COPs, coefficients of performance, and SCOPs. Again, nothing really that should worry heat pump manufacturers. Lighting has gone up from 45 lumens per watt to 75 lumens per watt. And in terms of ventilation, only one very minor tweak. The heat recovery efficiency of MVHR has gone up by 3%. But again, most modern MVHRs are in the 80s or the 90s anyway, so it really shouldn't be a problem. Okay, so this is now consistent with the rest of the UK, which obviously a lot of the manufacturers pushed for. Otherwise, you could have this weird scenario where one product from one manufacturer is compliant in England but not in Scotland, or vice versa, and it gets really difficult. Now it's standardized across the UK. We've talked a lot about zero emissions heat and moving to zero emissions heat in the future. Mindful this time around that actually the standards that the government have written aren't going to result in full electrification of heating just yet, and we've seen why, because of the issues with supply chain, number of installers, running costs, things like that. But we don't want to make it too difficult in future for homes to retrofit and change their heating to a heat pump or zero direct emissions heating system. So again, this is similar to what other regions of the UK have done. They've written some guidance in the Domestic Building Services Compliance Guide about how to design space heating systems so that they run at a low flow temperature. So they've decided that it should run at a low flow temperature of less than 55 degrees Celsius, which makes it easier to plug a heat pump in future, because that's kind of the operation temperature that they run at. Okay. Also has another benefit in that it improves the efficiency of boilers today. There was some concern, obviously, as you bring the flow temperature of your heating circuit down, you do need larger and larger radiators if that's the heat emitter of choice. And there's a risk, actually, you could have a radiator that was so large that it wouldn't be sized, it wouldn't be located correctly in the building, and that could have some unintended consequences as well. So there is some concern about that. Most people favoured this. They said this is a sensible thing to do. You know, it helps boilers now, but it also helps adoption of heat pumps in future if they're not there already. So they have introduced this flow temperature limit of 55 degrees Celsius, and that would have to be confirmed by the heating engineer when they commission the system. Further changes. So TRVs are now required. So if you replace a heat generator, if you don't have TRVs, which should be pretty rare, you'd think, but if you don't have TRVs, they are now required at all times on radiators. If you replace a building service and switch the fuel, that fuel you're switching to shouldn't result in an increase in emissions or energy demand. Generally, that doesn't happen too often. The only time it might happen is if for some reason you switch off electricity or gas to like oil or LPG or something, which would be quite an odd thing to do, really. If you've got a gas combi being replaced, there is some legislation from the EU that came a few years ago, which hadn't yet been incorporated in Scotland, but they've now written it into their standards, even though we're not obviously in the EU anymore. So if you replace a gas combi, you've got to then also add flue gas heat recovery or weather or load compensation, so like these Google Nest controls or smart thermostats. Okay, and again, that's something that's been written into the DBSCG. So I want to touch on overheating. So overheating is a slight change of tack, but it is still very relevant to Section 6. So the government were pretty concerned with overheating. So they looked at this, they did a lot of research. They were worried with climate change and sort of the urban heat island effect as well, heat waves. There was evidence to show that actually the impact of overheating in homes was rising. Okay, so you can see some statistics there. I don't need to read them out. But obviously, again, we've had a push towards more well insulated, more airtight homes, which is great for energy efficiency, but not also great for overheating. Okay, so it started to become an issue that the government were concerned with across all areas of the UK, not just Scotland. Okay. Why do we overheat? As I said, we're pushing for more and more insulation. We're pushing for better and better air tightness, glazing and shading. You know, developers, architects like their big windows. Not so good necessary for overheating. Internal gains, we all give out heat, and it's a particular issue in heat networks as well, where there's distribution pipework running around the building with high temperatures in it. If it's not insulated very well, you get all the heat losses into that building, causing some quite scary temperatures in the summer. So what did they do? Rather than using SAP to calculate overheating, which is what currently happens, there's been a change, and SAP will no longer be used to calculate overheating risk and report on it. There's now a separate procedure which is written in Standard 3, I think it is, if I remember rightly, but we'll go through it in a second. The buildings in scope, obviously domestic buildings, but also we're looking at multi-occupancy buildings as well, so not your traditional domestic buildings that come under Section 6 domestic, basically where anyone sleeps or where there's vulnerable people. they also are in scope for running through these overheating checks. Okay, so talking shared occupancy, self-contained units, things like that, care homes, flats, student accommodation, that sort of thing. So there's now two different methods that can be used to demonstrate compliance with the new standard, and that's something called the simple method or the dynamic analysis method. So the simple method is a very prescriptive approach. You're given an elemental set of standards to meet in terms of your amount of glazing you're allowed and the amount of free area you need to remove that heat. And that's based on sort of type of dwelling, floor area, and how many exposed facades it has. Okay, can you cross ventilate through that building? And there's different standards depending on whether you can or can't. Okay, that is not done in SAP anymore. That's a separate procedure completely. The dynamic analysis method, that is using dynamic thermal analysis, or DSM, sometimes it's known as, against an existing standard known as CIBSE TM59. And that's basically 3D modeling, much more in depth, gives much more design flexibility than the simple method for buildings that struggle. Okay. Either method is acceptable, but the simple method is very prescriptive. And obviously, if you can't achieve compliance that way, you've got two choices. You either change your building design, not a lot of developers like doing that, or you go down the dynamic analysis method, which gives you a bit more flexibility and a few more tools at your disposal, so to speak. Once that analysis is done, obviously that information needs to be provided to the homeowner as well. They need to know how to mitigate overheating. It's a quick start guide, which has a new section, or should have a new section, staying cool in hot weather. And that should explain any systems used to mitigate overheating risk, anything specific to that building that the homeowner needs to know about, and provide information on how to use controls and things like that, shading systems, which are used as part of the solution for overheating. Section 7, obviously I'm really only talking about section 6 today, but section 6 and section 7 are very closely linked, so it's worth touching on what's going on in section 7. Section 7 has been revised, and that's mainly to reflect the 32% uplift we've seen in standard 6.1 and the use of SAP 10 as well. Okay, so now in section 7, if you meet the TER, TDER, so standard 6.1, you've achieved compliance up to aspect gold level 1. Okay. Previously, it only used to go to aspect silver level 1, achieving compliance. So because we're now 32% better than section 6 2015, we achieve a higher level in section 7. Okay. Apart from that, there's no other changes to section 7 at all. So it's just that slight changing of the goalpost, I suppose, about what level you achieve from being building regulations compliant. Okay. SAP 10. I've talked a lot about SAP 10 already today. Mentioned it a lot. Apologies if I've used too many abbreviations, but SAP 10 is sort of our bread and butter here at Elmhurst. SAP is the energy rating methodology that Section 6, and in fact all versions of energy standards in the UK, utilise for calculating their results. It's not changed since 2012, and that was probably developed a year or two before it actually came into force in 2012. So it's probably over 12 years now, really, that we've seen a change in SAP. And that's really important because there's been lots of advances in technology that can't be reflected, couldn't be reflected. Obviously, we've seen cost change hugely, even in the last year alone. But in the last 10 years, the cost of different fuels has changed a lot. We've seen carbon intensity change already. We talked about that. And primary energy, even though that's not in compliance metrics, is something that's shown on the EPC. But also more research, influences how we calculate our hot water demand, how we calculate our heating patterns, lighting demand, and that is then fed into the methodology to try and make it more accurate every time SAP changes. Okay, so lots of different areas of the SAP methodology has changed. If you're a SAP assessor, you'd see the impact of this because there's some different data fields. A lot of it's tucked away under the bonnet, so to speak, in software. but you see the impact of it when you look at your results and compare it to previous versions of SAP. So if we look at cost, carbon, and primary energy factors, they've been changed since SAP 2012 quite significantly, actually. We looked at carbon already, so I don't need to go over that. We've seen what's happened with electricity. So whilst electricity is great for carbon and it's better for energy, it's not necessarily so good for cost. And that is still the case in section 6 2022. Okay. So the cost of electricity in SAP, at least, now actually if you look at your fuel bill, this is already wildly out of date, but in SAP, the cost of electricity has actually increased since 2012. It's by no means close to what you're probably being charged, but it has gone up. So whilst electricity is great in terms of carbon, and there's obviously a big push towards electricity, if you assess the same house in SAP 10 compared to SAP 2012, you would see a lower EPC rating, and that does puzzle a lot of people. And that's just because they're different metrics reporting on different things. Okay, see there's been a little bit of a change to gas, oil, LPG, but not wildly different. The amount of reward you get back for exporting electricity has been slashed as well. Okay, so that's been massively reduced. So all of that incentive you got from selling your electricity back to the grid has really gone away, and you're now better off using the electricity on site in the dwelling itself. To put that in a bit of context, BRE produced a table where they showed different dwellings and their scores in SAP 2012 and how they would then be, how they would result in SAP 10. And the main change is electricity, because we've seen the costs go up. So for example, an 80 rated building in SAP 2012 would come out as a 67 rated building in SAP 10. So that's a huge change, really, just from that change of fuel costs. Minor changes for the main fuels. Conversely, LPG and oil have got better because their costs have come down. And biomass, their costs have gone up, but not by as much. So the cost factor is kind of counterintuitive to what government are trying to achieve. We're trying to move away from fossil fuels and onto electricity. And at the moment, at least, because electricity is quite heavily penalised with green levies and things, it doesn't quite play out that way. And there is some decisions to be made in the future about how they figure that out. Now we also have the environmental rating on EPCs, which is based on carbon, and this is the opposite. So we've already seen what's going on with electricity's carbon factor being slashed from 0.5 to 0.14 or 0.136, and that means your environmental rating shoots up. So if something that was achieving an 80 now achieves a 98, which is basically a C rating to an A rating, through no change to the building other than the goalposts changing in terms of carbon factors. Okay. Thermal bridging. Again, this is probably a bit more detail for SAP assessors, but the default Y value. So if you have no information at all about your the developer's thermal bridging or how they're planning to address it, you have to use a default. Defaults are always poor in SAP. In fact, this one's got even worse. It was 0.15 in SAP 2012. So you really probably won't comply using a default. There's a couple of other junctions that SAP assessors need to measure relating to room in the roof scenarios, and some default site values. So these are if you've got an individual junction which you don't know a detail for, you have to use a default site value. And again, some of those have been increased as well. So it can make homes that have party walls and rooms in the roof quite tricky to comply if the assessor and the developer can't find a detail to avoid using that default. Thermal bridging, sticking with thermal bridging again, there's this weird type of thermal bridging called point thermal bridging, which isn't categorized within SAP assessments previously. It's where you just got a sort of an individual structure or something penetrating the insulation, and it's not really modeled at the moment in SAP. Now there is an option for a SAP assessor to account for that in their SAP assessment, should they have it. Lighting's changed. This is quite a significant change for SAPSS as an industry. So previously, we used to simply count the number of fittings and say how many were low energy, and the percentage of that would then be work out through into energy savings. But it was deemed that most, if not all, light bulbs are low energy now. So just saying one is low energy is a bit ambiguous. We need to go into a bit more detail than that. So now the energy assessor has to find out the performance of each individual fitting, including its power and its efficacy, as we call it. So different types of light fittings will have different performance, and we have to enter all of that information into our SAP assessment. And that gives a much more accurate calculation of lighting energy demand than what previous versions of SAP used to do. Does mean a bit more information gathering for the SAP assessor, developer, and unfortunately data entry as well. Heating controls, we don't sort of call them weather compensators or load compensators anymore. We just refer to them by the ERP class. That's class 2, 3, 4, 5, etc. And the SAP assessor can only pick those from a controlled BRE database. You can't just enter your own details in. Community heating, this is a BRE terminology change. They didn't like the term community heating, so they changed it to heat networks. Okay, and that was to more accurately reflect that a heat network could be, you know, one heating system serving 2 houses, or it could be one large heating system serving 200 houses. They felt heat networks better represented that range of scale, really. CHP has changed a bit. Again, this is all about how the electricity grid's decarbonised. You used to get a very high reward for using CHP because you were generating electricity rather than using grid electricity, which was very high carbon at the time. But the trouble is electricity is no longer high carbon. So the benefit of using these systems has sort of gone away. And they actually found out that they're more carbon intensive now than just using an individual gas boiler because of the effect on the gas efficiency. So they've revised all of their factors, again in SAP. Well, I won't go into too much, but they've revised their carbon factors to be higher than they were previously. And you get penalised if it's an old CHP system as well, rather than a brand new one. And depending on how it exports the electricity, whether it goes straight to grid or whether it uses it somewhere else, you get different performance. Again, that's something that the engine kind of takes care of itself, but SAP assessors need to be aware of. Now, as I said, technology is changing all the time. Certainly there's lots of new sources of heat networks that just aren't covered by SAP. There's so many new and innovative sources of heat recovery that are being used in heat networks, and SAP can't keep up, to be honest. It's only being changed every 3-4 years. It just struggles to keep up. So rather than trying to create a new type of heat source for every single type of technology that comes out, the BRE created 2 new categories to cover quite a lot of different scenarios. So high grade heat and low grade heat. And that basically is where you're recovering heat for a heat network. And if it's fed directly into the network, it's high grade. If it then needs to be boosted somehow by another source of heating, that's low grade heat. Okay. So some examples that they gave for high grade heat could be power stations, could be waste combustion, things like that. Low grade heat, heat recovery from data centers, refrigeration processes, brown. So we talked about ambient loop heat networks before. They're classed as low grade heat. Okay. So if you have those types of heat recovery, a SAP assessor can now just reflect those as high or low grade heat without worrying that this very specific type of heat recovery may not be in SAP itself as an option. There's some changes to distribution loss factors. So again, how SAP assessors reflect the loss factors from heat network pipework has changed. You now have to say whether it matches a CIBSE code of practice or not. And if it does, you get a DLF of 1.5. If it doesn't, you get a DLF of 2, which is quite penalising for the calculation. There's some changes to mechanical ventilation, more about how the ductwork's insulated. So the SAP assessor now has to reflect how much or how long the ducting is, and how much insulation has been placed on it, and they call that, there's some definitions for level 1 and level 2 that they have to satisfy. Also, there's a bit of a push towards actually reflecting on-site performance of ventilation as well. So a lot of ventilation systems, they're tested in laboratory conditions, and they'll say they achieve a heat recovery of 88%. When you actually install it with all the ducting and everything, that can be quite different. So SAP now has the ability to put the actual measured specific fan power into the assessment, rather than relying on what the BRE have classified it as, because as I said, when a ventilation system is installed, it can perform quite differently to how it was tested in the lab. Okay, so SAP assessors do have the option, if they're given a commissioning certificate, they can put that data in to make their calculation a bit more accurate. We now have to enter showers, because the calculation of hot water demand under the bonnet of SAP has changed quite a bit. So we now need to enter showers and their flow rate, and also instantaneous showers as well, which were never accounted for before. PV, there's some changes to PV. We have to tick whether the meter is export capable. Now, Scotland standards have already said, well, even if it is export capable, we're not going to give you any benefit for it for compliance purposes. But that exported electricity will show a benefit in terms of the EPC rating. So it's still an important consideration for the assessor. Again, in the interest of accuracy, we can use an MCS shading factor. So when a PV array is designed for a building, the MCS installer has to calculate a shading factor, and that takes into account different obstacles and things. If the SAP assessor has sight of that, they can plug that into their assessment, rather than relying on generic non-significant, modest, heavy options that SAP gives. The 2 new types of technologies can now be accounted for. So PV diverters. So this is where you have a system where there's excess electricity generated used to heat an immersion heater, and therefore provide low carbon hot water. That can now be accounted for. And of course, as I've said already, if you have a battery store, you can account for that as well. And they're very useful, particularly in Scotland, because that excess electricity, which would otherwise be sent off to the grid, won't be rewarded. So using those technologies does give quite a big boost to your compliance results. Different options for connection. Again, I won't dwell on this too long, but it depends on how your PV is connected up to the building, will determine whether you get benefit on your carbon emissions and your energy use and your fuel costs. We now have a differentiation between a roof light and a roof window. So a roof window is a opening in the pitch of the roof itself, kind of like your Velux really, and they're treated the same way as a window in terms of establishing the U value, whereas a roof light sits above and out of the roof structure on curbs or upstands, and they're treated slightly differently in terms of how their U values are assessed. So therefore they're categorized differently in SAP assessments and compliance standards as well. Okay, so to conclude, been through a lot there in a short space of time. New standards come into force 1st of February now, not 1st of December. What we think will happen, most homes will either stick with mains gas, or if they're not on the gas network, they'll be looking at heat pumps, and obviously heat networks will have quite a big role as well. All dwellings have to undergo air tightness testing. There is no sampling anymore. There's new overheating procedures which don't rely on SAP anymore. There are separate procedures in section 3 to mitigate overheating risk. SAP 10 is coming, which has fundamental changes to the cost carbon factors for electricity, which have big impacts on your EPC rating and your carbon figures for compliance. Design SAP 10 is our software, which we are producing, which we are very, very close to releasing to our SAP assessors to allow them to model against the new standards. Okay, and that's the end of my presentation. So thank you very much for listening. We do have some time for questions. Feel free to unmute yourself. I'll be happy to take any questions if anyone has any. will stop sharing so I can actually see. Silence. No problem. If you do want to put your question in the chat, feel free as well. If you don't want to speak up.
Jason, I'll just come in with one very quick question. Firstly, thanks very much for the presentation. Hugely interesting, much appreciated. The question was just in general terms about where we're moving in general direction in Scotland and how it compares to the likes of Passive House Standard. You may remember about where there was a private members bill lobbied earlier on this year, which asked for Scotland to move to Passive House Standard or a Scottish equivalent. And I'm just wondering how far away are we from the kind of passive house level, and where are the kind of gaps to, and what are the kind of benefits or otherwise of moving to passive house? Quite a long question, but if you could summarise it very quickly, that'd be appreciated.
Yeah, well, I think the key things in passive house are very, very, very well insulated fabric, very, very airtight buildings, and in a lot of cases, no sort of traditional heating at all. I think even where we're going in the new build heat standard won't get us to passive house yet. From what I gather, it's still expected that you'll need a traditional form of heating system, albeit it will probably be a heat pump at that point, not a boiler. I don't think we're there yet. I mean, the U values are coming down, but I don't think they're at passive house standards yet. Air tightness is coming down, but again, not quite there yet. So I think we've got a bit of a way to go. I don't think we'll be there by 2024, 2025. Whether the update after that, if there's a further update after that, that might get us to passive house if that's the way the government want to go. But yeah, certainly I don't see us getting there in the next 3 years, 4 years, I think.
Okay, thanks. And just for my colleagues' information, we do have a LABSS equivalence document which covers how we would look at energy design not covered by certification of design. So we are looking at upgrading that to reflect the changes in 2023. So that's something hopefully we can tackle early next year as a kind of aid for verifiers when checking against the new design standards, which, as you've alluded to, Jason, is quite comprehensive. So it's important that we get the verification rule right, and we recognise that the equivalence documentation played a role in that. So we'll tackle that again in the new year. So that's all from me. If anybody else has any other questions, just chip in.
No. Can I just ask one question, Jason?
Yeah, sure.
On the actual logistics, are you going to have a SAP package ready for your users in time for the upgrade in February? And will there be time for training them? And for us in building standards, is it going to be noticeably different straight away? Or are we going to have to hunt through the document to see the difference between the SAP 10 as opposed to SAP 12?
Yeah, number one question really that we're getting from our SAP assessors: when is your software ready? We're very, very close. We're actually, so we have to go through an approval process with BRE, and they have to basically check that our software is doing what it should do. We expect to be granted approved status in the next couple of days. At which point we will deploy that to our members. We don't want to hold up members. That was the main reason that it got delayed from December to February, is because the BRE approval process was turned into a bit of a nightmare. I won't go into it too much, but it's been dragged out a bit. It's been a bit difficult. So hopefully, maybe this week we'll have something out to our members which will allow them to start modelling to the new standards. In terms of what you'll see at building standards and in terms of reports and things, the software itself is quite different to our previous software. The main change is it's an online based solution, not a desktop based solution. In terms of the output report that you get, that shouldn't be that different. We've pretty much based it on the previous report and obviously updated it for the new standards and the new metrics of energy and things, but it will look pretty familiar to what you're used to. But for SAP assessors, it's quite a big change. And there is training out there that we do. We do obviously lots of manuals and videos and things, but it's quite a change for them. Reports for you shouldn't look that different, I don't think.
Thank you very much.
Thanks, Jason. I think we'll call it quits there. If anybody has any questions for Jason, colleagues, just drop myself an email and I can collate them and we can sort of catch up, Jason, after we've done the two domestic and two non-domestic sessions and see if there's a sort of Q&A document or something like that to be prepared. So if any feedback, guys, anything you want us to kind of cover in maybe future training sessions, then we can discuss that with Elmhurst going forward, I'm pretty sure. So just drop me an email. And I'm pretty sure, Jason, you showed that barcode there. So if you're looking for any feedback on the presentation, I'm pretty sure you'd be delighted to get it.
Yeah, thank you very much. Okay.
Excellent. Thank you very much. Thanks, everyone. Cheers, Jason.
Thank you all. Take care.